The first thing we're going to look at is the digital signal, the DALI signal that goes from the switch to this pulse width dimming module. And you can see that when I hit the button to its presets, I get some reaction on the scope. So let's look at what this digital signal actually looks like. I can get a continuous output pretty much by working the slider. And the first byte of the DALI signal is the addressing byte, and in this case it's saying, anybody on the line, answer up to this command. Now the second part is the command, and that is varying arc powers depending on where I am positioning the slider to. So that's our digital signal that goes to the module. Now how does the module respond? Now we're at full output on the module, and so this is about 12 volts right here. This is our 75% command, and you can see it's cutting a little more than 75% off of this waveform. There's our 50% command, and you can see that it is just about 50-50 on time and off time. And there's our 25% command. So this module isn't doing too bad. It's doing okay. That could be a little longer maybe. But there you go, 100, 75, 50, 25. That's your pulse width modulated output. And then of course we have the slider. And there you have it. Now of course this pulse width modulated output is what is actually causing the LEDs to dim up and down. So that's the signal going straight to the LED strip.
Now looking at the data for our 0 to 10 volt luminaires, we discover that they are all over the map when it comes to lumen output. You'll note that the old CFL ballast at 7.73 volts control voltage didn't even dim down at all. But you'll also note that these control voltages are consistent. Now, we get a much better response from the digital ballasts. These are reading a little high, but we've got the ROVR, and it is working just great. And the LUTRON H-series is also coming in very well. And that one's a surprise because this is a proprietary system, and so we didn't even know that this was going to work on standard short address DALI. Let's look at the charts. So folks who've been following along here should not be surprised by the 0 to 10 volt response we get from the ballasts. We should, in a perfect world, just be seeing a straight line from 0 to 100 with these following along, but you'll note they're all over the map. But the control voltages were consistent throughout the 3 ballasts tested, so the differing current sources did not do anything bad to them. But wouldn't you like to see something more like this? This is the response of the digital ballasts, and you'll note this one is absolutely perfect straight line as far as we can tell from our little analysis. So this shows you that you will always have to characterize your 0 to 10 volt Luminaire output, but in a digital system you're going to be fairly close to what you have commanded the lights to go to. There's a few outliers here. These are quite high. This is quite high. Nonetheless, this is not bad at all.